you very much. Okay, so hello everyone. I will talk about something different from previous speakers. It's like a kind of interdisciplinary between combine together physics and social science. So what we call it computational socio-economics. That means how we can use real big data, real big data to review some insight, underlying insight or underlying regularity in social system or economical system, and to do some prediction if possible. So anyway, there is a kind of big perspective, but I will return to this page after some introduction or some examples. Okay, that means basically if we have huge data, we can do so many things. Okay, then including some global analysis and also some individual level analysis. Okay, so I will first show you some examples, and in the end we will go back to this page of perspective. So first of all, if we imagine some kind of global analysis, we can use the data from satellite. That means we have some remote sensing data. For example, this is nighttime light from space. So from the space, we can see which city in the night is somehow they have so bright night, like in Beijing and Tianjin or somewhere. So this is really night. And if we have this kind of data, so we can draw what we call the poverty map of the whole world. Okay, that means if we combine some kind of machine learning method like CNN, like some deep learning, together with what we already know, this household income, so we can do some kind of learning to connect the remote sensing data with the household income. So we can draw this kind of map, so directly know which place is the poorest place. So this is just some introduction, simple example. So if we go further, we look at the national level. So privacy is a kind of global level. So here I show one example is like, if we know some kind of import and export data of so many products, so for countries, okay, so we can see if some product can only be produced by a few countries, that's usually it depends on high techniques, okay? So we call this product is of high quality, okay? And in the other side, if some country, they can produce so many high quality products, we call this country is of high fitness, am I right? So this is a kind of iterative refinement like the Kleinberg's Hits algorithm. That means the fitness of country depends on the quality of product it produced, okay? And the quality of product depends on the fitness of country. For example, if high fitness countries produce this kind of the target product, this product should be of high quality, okay? So the vector of quality of country depends on the fitness of the vector of the fitness of country depends on the quality of product, and inversely the quality of product depends on the fitness vector of the country. So this kind of iterative refinement will go convergence, and we can eventually obtain the fitness of countries and the quality of products. So if so, we can have some kind of, we can draw some map like that. So that means here is the fitness of country, and here is the average GDP of the country. So if you have high fitness, that means your country can produce some high technique product and is of high competitive, okay? But your GDP per person is low. Like this is China, okay, here is China. So that means we predict you will go a fast developing way because you already have a high fitness, but your GDP is low, so you can go fast, okay? So, So this is in such kind of area. But inversely, in contract, if you have some very low fitness, but your GDP is high or not, so you will have some, not so good future. Okay, so a recent paper in Nature Physics that shows one. This is a very famous paper. After it appears, suddenly everybody knows. That means, so using this kind of method. So anyway, so if we want to predict the future GDP, so we can look at this map and we find if this is the target country. We look at their labors. Their labors, that means with similar fitness and with similar GDP. And we see, okay, how, for example, this is the way, if we want to predict the future GDP of this target country, we look at 5 years ago, which country is in the neighborhood of this country, of this country in the current stage. And we see how this neighboring country will develop in this map. So we use some weighting method to predict this one. Okay, and eventually you will find that this kind of 5-year prediction is much more accurate than previous method. So this is a kind of what we call, if you have so much data, even we don't need some economical rules. We don't need some kind of economic knowledge, but we can do a kind of more accurate prediction than previous or than traditional economic method. Okay, and sometimes things will be even more interesting. For example, this is a paper in 2 years ago, and this stage we look at how innovation and how this internet activity can predict the GDP growth. Okay, so this map is for the internet users. We find about 200 million of Weibo users. Weibo is in, I'm not sure, someone may not use Weibo. In China, or in Chinese, 新浪微博, okay? So this is a kind of, should be a kind of Twitter in China, okay? Somehow like Twitter in China, okay? So, okay. So we have 200 million of users, and in different cities, it's about 300 cities in China, okay? So we look at just 2 variables. So one is the total GDP of this city, and another one is the total number of active Weibo users. That means a kind of proxy data for the internet activity of the city, okay? And we also have another kind of graph is about the correlation between GDP and innovation. Innovation, we use the number of IPs applied for this city, okay? So, but it's almost the same. So I just show the internet users, okay? And if you look at this one, this is the number of internet users, active internet users in Weibo, and this is the GDP of the city. Okay, each data point is a city. So first of all, you will observe that there is a high correlation. Okay, that's correlation for, if you look at the Pearson correlation is higher than 0.9. Okay, so that means if one city it has high internet activity, okay, it also have high GDP. Okay, this is easy, but you will find some cities are abnormal. That means some cities if you look at this kind is idols, 重左来宾中位. For some Chinese students, you may know this 埃尔多斯从左来宾中位. Okay, so maybe you understand, maybe not. Anyway, this is 4 cities in China. They have somehow with the similar internet activity, they have much higher GDP. And in another graph I didn't show here, it's of the similar innovation, the number of IPs applied for each year, they also have much higher GDP. That is strange. Why a city has lower internet activity, or the city has small number of IPs, they have high GDP. Okay, this is, there's something wrong? You don't have power, or? Okay, it recovers some. Maybe I can. Okay, it's power off, or? Okay, thank you very much. Okay, so if you look at the economical structure of these 4 abnormal cities, you will find every city of this kind, it's highly depends on some special natural resource. For example, like miles, like oil or something. Okay, so this kind of city, they do not have a kind of ecological or a kind of very healthy economical system, but just depends on some very specific resource. So after 2013, there, because price decrease, I mean the huge decrease of oil and miles, so their financial system crashes. Okay, like in Eldos in, maybe you remember that in Eldos we call it host city, 鬼城, host city. Like they have so many high buildings, very beautiful, but nobody living in because the economical, the financial system crashes in Eldos. So that means we have some kind of different perspective to look at the risky of the economical system of this kind of cities. Because if we just look at the GDP, we say, okay, this city looks good. But if you look at the economic structure to see, they have diverse industry or not. Okay, and their major industry is sensitive to the world pricing or something, or it's not. Okay, so that means based on some kind of simple analysis, we can have different viewpoint of risky. And now the National Development Bank use this kind of system to re-estimate the risky of cities and to make decision of how much money the central government can give or can transfer to this kind of city. Okay, so this is one thing we can do. This very interesting. And another thing is not public, just accepted for maybe will be published, should be published in early next year. So that means if we compare, okay, so in that page we predict the economical development just over online data. Okay, so in that page we will compare the online data and the offline data. So we have a very small subset. Now we have a big subset, like more than 26 millions of job seekers CVs. Okay, job seekers resumes. But now at that stage, okay, what? Okay, at that stage we have just 113,000 of offline job seeker CVs. Okay, this is small subset. Okay, 13万多. Okay, very small subset, 100,000. Okay, and then compare with we have 400 millions of online web users. It's about 3,000 times of difference. Okay, I mean the size of data set. But you will find that it's like the offline data has much higher power of predicting power than the online data. That means we use a very small subset, but we can have much higher accurate predictions than the online data. Okay, now we use such kind of even big data set of job seekers. Okay, that job seekers, that means like because they submit their CVs into some website like 15 job 智联招聘 中华英才网 okay, something I cannot translate to English somehow. Okay, and this is a big website. They have so many job seekers, like sometimes like in 智联招聘 they even have like more than 100 millions of job seekers. Okay, so it's real big. Okay, and in such kind of data, in such kind of website, the job seeker, they will submit their CVs. That's including which high school, the university, the graduate study, undergraduate study, your major, and which firms or which companies you have worked in the private stage. Okay, so we know your movement, you move from Sichuan province to Beijing or to Shanghai, or you move from Shenzhen to Hong Kong or something. Okay, so basically we know the flow of tenants in China, and based on this kind of data, we can do some prediction about the economical development. Okay, so this is some other things are much more interesting, how to use offline data. Okay, and based on such kind of CV job seekers data, we also can do even more to see the regional industry, the learning how the regional industry development. For example, here is we are working with MIT and we look at data from China, you already know, and also some data from Brazil. Okay, this is really big, really big. This is covering even almost 100% of the human resource market of Brazil. Okay, and it's the number of the data is also really big. Okay, for Brazil it's really big. That's kind of big. Okay, so in each resume or in each record, okay, we know that's the ID of the work and which film now it is now, and he is working in which field, and this film is in which region, I mean state, which state in Brazil. Okay, and the occupation of this work, like it's teacher or it's a researcher or it's a something. Okay, that's the occupation. It's in totally they have about 500 occupations. Okay, and the industry. The industry, they have been classified into 21 different classes, categories, and the subclasses is more than 600. Okay, so based on this kind of data, we can draw a map. We can draw an industry space of Brazil. Okay, like two industry. If they hire workers with similar occupations, we see these two industries are similar to each other. Like for each for this six line. Okay, here it's for this 6 line. Oh no, not 6. For this 501 occupations, we have for each industry. Okay, for each sub industry, one can draw a vector of about 500 dimensions. Okay, and each is a ratio of works you have hired in this kind of occupation. Okay, and if we do some kind of normalization and we measure the cosine similarity between these vectors, we know the similarity between two sub-industry. Okay, and in total we have more than 600 sub-industry. Okay, and this is in such kind of map. So the size of the node, each one is a sub-industry, and this is a 21 first class. And here is more than 600 nodes in this map. Okay, and the size of the node is the number of work it has hired. Okay, so that means how big the industry. And the connection between nodes is a similarity. Okay, it denotes a similarity. Okay, I will see my phone for the time. Okay, otherwise I don't know the time. Okay, it's good. Okay, here is the connection. It means how the similarity between two industries. Okay, so now we can have this kind of map. So based on this kind of map, we can do some interesting analysis. That means if you look at the development of the regional industry, we will see which kind of, so because if you are the chairman of a province or of the state or of Hong Kong, okay, so you will see which industry I should develop or I should investigate or I should push on, okay, in the next stage. So everybody want to have to develop first. At first, everybody want to develop some industry in the central part. Because if you have a successfully developed industry in the central part, it will be it will be benefit for other industry and connected to you. Okay, am I right? So, but this is not easy because everybody want to have some intelligent manufacturing or some financial techniques, but it's not easy. Okay, so you have to balance. Somehow you want to develop the central industry, and somehow you need to or you have to at first stage to develop industry who is the labors of the industry already successful in your region. Okay, so that means so we have two channels of learning. The one is what we call is industry learning. Here is for China. Here is for Brazil. The data of China is a kind of of less quality, okay, of poor quality, somehow like that, okay. So what we call this kind of industry learning, that means if you look at your province, okay, if assuming you are the chairman of the province, okay, and if you want to say a target industry, okay, so you just say, for example, if you want to develop this kind of industry, this is target industry, you see the neighbors of this industry. If there are so many neighbors of the target industry, there are so many neighbors of target industry have already been successfully developed in your province. So you will have a higher probability to successfully develop this target industry in the next few years, okay? And if you look around, I mean your neighboring province, okay? You look at your neighboring province, that means the province nearby you, okay? In the geography space. And if the target industry has already been successful in the neighboring province, so you will have a higher probability to successfully develop this target industry. Okay, that means this is what we call neighboring learning. Okay, so this is two channels of learning. So coming together, you can make this kind of regional economical development to some kind of optimization problem. Okay, this is another thing I like to show you. Okay, we just go from this global, okay, to global wide, or to national level, and to regional level. And now we go to the urban level, to city level, okay, and at least we go to individual level, okay. So another thing we say, how we use data to do some urban administration or urban management. So this is one thing. It's like so here we just develop a very interesting app in the mobile phone. It's like at each time we show two pictures of street view pictures, two pictures, okay, and we have 5 dimensions like the safety, okay, the beautiful, the greenness, and so on, the infrastructure or something, okay. So for example, here is the safety. We show for each person, or not each person, for one person, okay, this volunteer, okay, look at these two pictures and you choose which one is more safe or which one is safer, okay. So we can also show you two pictures and you see which one is more beautiful. And it likes that we show you two pictures, two girls, and we ask you which girl is more beautiful, something like that, okay, but just for street view picture. Here is what we have done in Chengdu. Okay, Chengdu is my hometown city. It's like we have 20 million of people, and the population is even higher than Hong Kong. It's big city. Okay, so we download so many street view pictures. That means we have millions of pictures from Gaode map and from Gaode and from Baidu. Okay, basically from this, right? It's a very cheap. We use a little money to buy some. Okay, and based on these millions of pictures, we use just like 8,000 pictures. 8,000 compared with millions is a very small subset. Okay, we use 8,000 pictures. We show to the citizen. Okay, we ask for about more than 200 questions for different cities. Some people they answer tons of questions, and some people just answer one question. Okay, so we have feedback. I mean, the feedback is more than 2 million of feedbacks. Okay, and each time we randomly pick up 2 pictures from these 8,000 pictures. Okay, 2 pictures to ask one question: which one is safer? Which one is more beautiful, or something? Okay, it's like this one. It's like just here. Which one is more? This is the urbanization. Okay, which one is more something? Okay. Okay, and based on this kind of feedback, we can do some deep learning. we return back to deep learning. So deep learning is everywhere, okay? We can do some kind of deep learning, what we call faster RNN, regional proportional networks. It's a kind of variant of the CNN, okay? And use this kind of method, we extract the features of the map automatically and to connect it with the score of different dimension, okay? So because when we have the 2 million of feedback, we can rank these 8,000 of pictures in each dimension, which is safer, which is more beautiful in each dimension, okay? This kind of 8,000 pictures, okay? And we do some deep learning to connect the features of the map with the ranking score, okay? And after that, this becomes automatically scoring system. That means we can just use the computer to determine the score in each dimension, to determine the score in each dimension for millions of pictures, not just 8,000. But the computer can give the score for millions of pictures, okay? So at that stage, we can know the whole city, where, because we have millions of pictures, they will be scored. They have already been scored by the computer, by the artificial intelligence, okay, by AI program. So we know in the whole city, where is the most beautiful place, where is the most have the highest greenness, and which place is of less safety. Okay, so because this program is directly reported by for the chair of the or what we call for the secretary, community secretary， 就我们市委书记、市长抓的一个一把手工程啊。这个 I cannot translate to English because even you cannot understand what we call secretary, community secretary. That means and the first hand, okay, the first hand, the chairman of our city. So it's directly reported to him, okay, and so he can understand the total, situation of the whole city. And this is for other cities, not for our city. It's some similar work he published in PNAS last year for some other cities, because we are in ongoing. That means what we expect is like, if the the managing team of our city, like Chengdu, they do some project, try to improve the safety or the greenness or some basic infrastructure of cities, okay, in some place. They spend much money and try to improve. So after 1 year, 2 years, or 3 years, because the computer can automatically scoring this kind of different street view picture, so we can directly know this kind of money, okay, this money has or has not bring some kind of improvement. For example, this is for analysis, not by our team. It's like, so here it means, so okay, this is 10 years ago, 7 years ago. After 7 years, that means, okay, it looks like much better. Okay, the score is higher. Okay, but this two looks like they don't have significant change. Okay, so that means we can not just know the whole situation of the city, okay, in different dimension, but we can also know the improvement, or we can, at least we can understand if you spend money, this kind of money can bring some change or not. Okay, so this is at the urban level. Lastly, I show you some I will show some examples at individual level. I mean, also by this kind of big data. So one example is this is just simply, it's like using this kind of social networks. Okay, using this kind of in even very small social network, we can predict the promotion and the recirculation. Okay, that means someone will be fired or will leave the company, and someone will be promoted. Okay, in the company. So we just use some OA system. OA system is like what we do some. Do some ordinary task in this kind of in the company, so we can this kind of actions and activities will be recorded in the OA system. Like you do some communication with other department in the company, and you upload some files, you download some files, you accept some task, and this task is combined with different people in the company, and also in sometimes crossing department, and you can submit some other like meetings, or you do some email inside your company. So we can draw a social network, okay, in your company, okay. So if you use this kind of data, we can also use this data to predict what we call the promotion or some kind of the recirculations or something, okay. So that means if in this kind of social network, if you have high degree, that means you have so many or high students, you are very active with, and you have so many contact with your colleges, and even you can look at the Hong Kong University, maybe the same, maybe not, okay. So if you have high degree or you have high coreness, that means you are in the core of this social network. So you will have a higher probability to be promoted, and less probability to leave this company, okay. And this is a very significant difference, okay. So that means the AUC is very high. Sometimes it's approach to 0.9, okay. So that means, so the networks and the data can, this is more than 2 years the data for a company. The last example, this is the last example in my presentation. It's what interesting is what we do some prediction about the academic performance of university students. That means in my university, okay. So something interesting is like, well, I just want to monitor the behavior data of students, because in Chinese campus, okay, almost each student in Chinese campus, we will have a smart card. Smart card means, okay, I will show you. Okay, this is a smart card, what we call, or student ID card, okay. So many behaviors are recorded by this smart card. Like you go to teach buildings to fetching water, because you want to fetch some boiled water, some hot water, you need to sweep this smart card, okay. And you go to have lunch, to have dinner, to have breakfast, and you want to go to the library, okay. You go to the library, or you go to the like art center, you will have sweep this smart card. And sometimes you borrow books and you select courses, okay, you also need this kind of smart card. So we have so many behavior data based on this kind of smart card. Now, what we want to do is try to predict your academic performance based on your behavior data before the examination in each term. So we can have really very high accurate, like more than, if we look at the Spearman coefficient, or we look at the Kindle-Tau. That means if the Spearman correlation is 1, that means what I predict your rank in your major, okay, in your department, is exactly the same with the rank after the examination, okay. If the value is -1, that means it's inversely. Okay, if the value is 0, that means it's just a kind of random guesses. Okay, it's a random choice. But anyway, we can have some about 0.9 the accuracy for different department or for different majors. It's a kind of different. Okay, but the higher can be 0.93, the lower can be 0.85. So it means 1 week before your examination, we will predict which group of students will fail in one or more than at least one courses. And what we predict, about 18% of the predicted students will really fail. Okay, so this is really of high accuracy. So how can we do that? We have three different kind of data putting together. The one is a private scores, okay, the private examination scores. Okay, that's, of course, it's have high correlation, because if you are a good student, you are top student in the last few terms, you will have high probability to be successful in this term. But it's not all the same. For example, for mathematical and for theoretical physics, the correlation is very strong. That means if in the first year of your underground study, your mathematics is not good. I mean, if you are in the mathematics department, okay, almost I can say you will be failed in the next year. But if for some other, like education, or like something you don't know, like 马克思主义教育, okay, maybe in Hong Kong you don't know, some 马克思主义, okay, Maxim or something. I cannot translate into English, okay. For some kind of, this kind of department or managers, even if you have, the correlation is weak, okay, so that means if you want to be good, you can be good at any time. It's a kind of different from physics and mathematics, okay, they are more basic. The second group of data is what we call diligence. Diligence is we try to estimate how many hours you have spent on studying. This is what we call diligence. That means how many times you go to library per month and how long you stay in the library. Because in our university, stay in the library, so many times we do some self-study, we will choose in the library. The library is very big, okay? And how many books you have borrowed from the library, and how many textbooks or how many related books related to your study within this group, and how often you fetch water in the teacher building, and okay, something like that. Okay, this is what we call diligence. It's the second group of data. And I show you here is orderliness. That means it's a kind of interesting. That means we don't look at your studying behavior, but we look at your lifestyle. Okay, that means orderliness. For example, underlying this kind of study, that means if you're living in a disciplinary life, so that means you can better control yourself, and if you feel some difficulty, you have a higher probability to overcome that. Okay, so here is what we call the shower, taking showers. Okay, in taking showers, each time we will use this card. So in this showering room, okay, and you have hot water outside. Okay, so you need to put in this card. So we know exactly the time you taking shower, okay, but we, of course, we don't know who's who. It's a kind of just some random ID, okay. Anyway, we can see this is one student, but we don't know your name. We don't know your mentor. We don't know, but we know this is one student, okay. And we know the time you taking shower, and we can see this is a kind of distribution, okay. We can look at the time series of your showering time, okay, and we estimate or we calculate the actual entropy. It's a kind of approximation of the second common entropy, okay. Anyway, it's a kind of measure about your regularity of the time series, okay. So this is 18,960 student, or almost all the underground students in our university. So the distribution of the actual entropys, okay. And in the left side, it means you have a small or lower entropy. So you are living more regular life. And we look at this one, okay. This is a distribution of your time clock, okay. This is 0, the early morning like 6, the noon 12, okay, the afternoon, like this afternoon 3 p.m. or something. Here is 3 p.m., 6 p.m., okay. So we'll find this regular student, okay, he usually taking shower around 9 p.m., okay, am I right? Okay, in the night, okay. But this one is someone who is living in irregular life, okay. It's of high entropy, okay. And he or she, okay, may have shower at any time. Just he didn't taking shower before around this kind of 3 or 4 a.m. But other time, another time he can take shower at any time. So it's a kind of irregular, okay. And this is having miles, okay. It's almost the same. So the regular student will have a mile in some scheduled time, okay. It's highly correlated with their study or classroom, okay. And the irregular student will go to this having. I don't know why. Anytime he can go to to have mild, but maybe not have mild, but just buy some waters or just buy some bread or something, okay? But anyway, he's not regular. And we will find if the ordinariness and the GPA for the 4 years, the 4-year GPA is highly correlated. So using some kind of simple ranking net prediction, even if you don't have this the score in the private terms, just use the behavior data like diligence, what we call D, and orderliness. We can do some kind of prediction. Okay, and if you combine with this kind of private score in private terms, okay, so you will have more accurate, sometimes more than 0.9. Okay. So this is all example I show you, and I don't have time. And now you can understand the perspective, what we call computational social science or computational socio-economics. That means sometimes we don't have social insight or economical insight before our study, but we just have data. But using some kind of data-driven analysis, we can have some insight that's even sometimes beyond the social scientists or the economics. Okay, so that's all. Thank you very much. Thank you.
We have some questions.
Will you show your last chart again?
Okay. This one?
Yeah.
Okay. Hi.
So the last example where you get student behavior data, I mean, what are you going to do with that? I mean, even you find that the ordinance can predict running performance.
Okay.
And what are you going to do?
Well, this is something very interesting, and maybe it's a kind of different from Hong Kong the regulation, because now basically we have in the technical or research team, we don't know who's who. We just have some random ID, but for each 辅导员, I'm not sure you can understand. If, like in China, we have some advisor, but this kind of advisor is not academic advisor. It's a kind of living advisor. Okay, 辅导员, what we call. Okay, so this for each advisor, they have about 100 students. They will do some guidelines. Okay, so they know who's who. They have this mapping, one-to-one map from this random ID to this student ID, real student ID. So they know who's who. Okay, so sometimes if the students have what we call, we have so many rules. If the student break the rule, what we call break the rule. For example, if for continuously for 3 days in the working days, for 3 working days, the student do not have swept car at any time. That means what we call, we lose the contact with the student. Okay, so we will see a warning automatically by the system, see a warning to the advisor, to the corresponding advisor. The advisor will look at the student if he is in the campus or not. Okay, so this is one thing. Another is some rule is related to this study. That means, for example, if this kind of, if one student he went to library about 13 times per month. This is ordinary. Okay, but for this month he went to library just 1 or 2 times. Okay, so we have a threshold. So he breaks the rule. She breaks the rule. Okay, her advisor will go to visit her to see if there's something wrong with her. And we also have another thing. For example, we have for this poor student, if he go to have meals and lunch for more than have lunch or dinner for more than 6 times per month.
But
okay,
I mean,
okay,
all the
okay.
examples you gave, I don't think they have to depend on the big data analytics. I mean, the counselor basically just look at each individual, because the counselor knows the behavior, just check the behavior on each individual student can take action. I mean, how that's associated with the big data analytics. All the examples you gave are individual cases. I don't think they have to be associated with this.
Okay, because what you have is really so many features and so many dimensions. Like you have so many, you have so many behaviors, or you have so many features of the student. Okay, so what I show you is already after analysis. after analysis. That means you have already know the insight, which kind of behavior is highly correlated with GDP or highly correlated with the future of the student. But before I show you this map, you have so many dimensions. So what we will see is we will do some correlation analysis and causality analysis so I can show this map. Am I right? Otherwise, you have so many behaviors. For example, how many times you go to these art centers? How much money you have spent in supermarket? This can also, but it's not relevant. Okay. But so after analysis, we know it's not relevant. Okay. Am I right? Thank you very much. 谢谢你的问题。谢谢。
Whether there are any outliers in the data set, it could happen that some students they don't have a very regular kind of dining patterns, but they still can get high grade.
Yes, we have. So you know that's in the individual level, the correlation is not so strong. But in the global, the population level, we look at some correlation, and this kind of system is not for talent, but just for some students. They may be internet addiction, like they do.
The row there is the correlation that you mentioned in the graph, row 0.1 something. It is the correlation.
Yeah, this is the one correlation. Yes, it's a correlation. Yeah, for one dimension, but they have so many dimensions. Okay.
We should stop here.
Okay, I think the time is already okay. Thank you very much. Thank you.